Hi, welcome to our pre-calculus. Topic today is verifying a trigonometric identity problem type 1. So an identity is given and we are supposed to indicate what are the steps in its derivation. So here is a statement of the identity, and as you click on these rules, what you see collection of rules that we have referred to so far. Algebra simply means you are doing plain algebra, that what you are doing is not related to trigonometry. Excuse me. Reciprocal refers to reciprocal identities. These are the identities we had with the sine being reciprocal of cosecant, and cosine reciprocal of secant, tangent reciprocal of cotangent, and so on. Then we have in our list of identities are the quotient identities. You remember tangent is a ratio of sine to cosine, and cotangent is the inverse of that. Then we had Pythagorean identity. Pythagorean identities are rules that we have for uh, handling a right triangle. These are essentially saying that a squared plus b squared is equal to c squared. We went through the derivation last time. Odd and even identities refer to the fact that trig functions at negative of u and the trig function at u itself, are they related to each other? So we remember that cosine and secant are even functions. So when you change u to minus u, the value of the function does not change. The rest of the functions were odd functions, meaning changing u to minus u makes the value of the function to become negative as well. So these are the rules that we have in front of us, and then we want to go ahead and check to see step by step which one of these things are applied. So for example, here 1 minus tangent of x quantity squared, it says it's equal to this expression. So the software is asking what rule was used to come across that observation of the rules that we have, which one of them. So was it algebra? Was it reciprocal identities? Was it quotient? Was it Pythagorean? Or was it odd or even identity that was used to arrive at this? And what do you think? Let's just quickly remind ourselves that some basic identities we use, these are coming from algebra, that are true for any expression not related to trigonometry. Simple ones, a minus b times a plus b is a squared minus b squared. A plus b quantity squared is a squared plus 2ab plus b squared, and a minus b squared, similar expression with the minus for the cross term. So which one of them was used? It was going from this expression to this one. What was used was just plain algebra. That is, if you want to see it, it was this one that was being used. If you have 1 minus tangent of x squared, that idea says square of the first one, which 1 squared is 1. Twice first times second, so here we have twice first times second. Here's first one is 1, second one is tangent of x, twice 1 times the other one is twice, so let's write everything 1 squared, 1 times tangent of x, and last one is b squared. B squared is tangent of x squared, and of course 1 squared is just 1. We write this minus 2 tangent of x, and we said our convention is to put the power on top of the name of the function. So going from the this expression here with parentheses 1 minus tangent of x squared to the second one, what we just used was algebra. Now how about from that one to the next one? We look at this thing and say, well, tangent of x is being kept, and we have 1 plus tangent square of x replaced by secant square of x. Which one of these rules is that? Well, of course, that's a Pythagorean identity, because Pythagorean identity, remember, 1 plus second one here, this is 1 plus tan squared is secant squared, and that is what has happened here. 1 plus tan squared has been replaced by secant squared. So which one? We are going to use Pythagorean, and let's see if we got it right. So hopefully it corrects. Let's try another one. So in this identity, it says 1 minus cotangent square is equal to cosecant squared minus 2 cotangent of x. From the first to the second, what are we using? Of course, just like the previous problem, this is an example of algebra being used here. 1 squared is just 1, cotangent squared is, well, cotangent square of x. Twice the first times second is minus 2 cotangent of x. So as of yet, we haven't applied any trig identity. Here cotangent is kept, 1 plus cotangent squared is cosecant squared. What identity is that? And that was Pythagorean identity. That's so Pythagorean identity, 1 plus cotan squared is cosecant squared 1, and cotan squared is cosecant squared. So all we have to do apply here is to say this is the Pythagorean type. Okay, and then we go to the next one. Sine squared minus sine to power of 4 is same as cosine squared minus cosine to power of 4. So first step here, we look at that, we see it's being written in this way. Well, what has happened? What has happened is that we have factored sine squared. So when you factor sine squared out of itself, you are left with 1. Factor sine squared from sine to power of 4, we have sine squared. So what is this? This is of course just algebra. Now for sine square, he writes 1 minus cosine squared. So 1 minus sine squared writes cosine squared. You see what happened? The first expression here became this parentheses, and that parentheses became this. How do we know that? That's just the Pythagorean identity. First one of them, this Pythagorean identity. Let me open this. So you see that it says sine squared plus cosine squared is 1. Now if I take cosine squared to the other side, it becomes sine squared is equal to 1 minus cosine squared. That is what's written here. And if I take sine squared to the other side, I'll have cosine squared is equal to that. And that is what has happened to the second one. Now from this line, third line to the fourth line, what has happened? All that has happened is that we have just multiplied. Cosine squared times 1 is cosine squared times another cosine squared is cosine to the power of 4. So that is just algebra again. and that completes the problem. Now, of course, here we are being guided by the software to choose certain identities. It is just the software is carrying out the steps, and we are just supplying the reasoning. In real life, you're supposed to do this thing by yourself. So I suggest that when you come to these problems, just look at the statement of the identity itself and try to go through the reasoning from left to right all by yourself without looking at what is typed here. Somehow guide yourself from one side to the other side to bring both sides to the same common value. Once you do that, then you go ahead and go through these reasonings as well, just so that you answer the questions. Let's try another one. Okay, saying cosecant to power of 4 minus cosecant to power of 2 is cotangent square, and this is a plus sign, so plus cotangent to power of 4. How do we see that? So here says let's factor. So he's factoring cosecant square out of these two. From 4 we have power of 2, and from power of 2 we have factored all of it. We are just left with 1. So what did we do here? We just applied algebra. Now, instead of cosecant square, we can write 1 plus cotangent square. Which rule is that? Well, that is the Pythagorean identity. Let's look at the Pythagorean identities here. Oh, sorry. What are the Pythagorean identity? So 1 plus cotan square is cosecant square. So cosecant square can be written in that style. Cosecant squared minus 1. Cosecant squared minus 1 is same as cotangent square, and that is the second piece. So that is equal to this, and this one is equal to that one. Now we just multiply. Now this multiplication has nothing to do with trigonometry, just algebra. Cotangent squared times 1, cotangent squared times another cotangent squared is cotangent to power of 4, and so on. So this we need the algebra, and then we are done with that. So problems in this section are just like that, and you can quickly go through it. Again, I recommend do not look at what you see here. Rather, try to go through a reasoning yourself from left to right. Use this as kind of a help or a hint in case you get stuck, but try to go from left to right all by yourself, and that's going to be much more instructive. Okay, until next time, good luck and God bless.